Welcome, we are Chocolandes, and in this video we will teach you how to make your own hot chocolate maker. So, let's begin.
Chocolandes is an electronic device made for serving and mixing drinks. With it, you will be able to select the speed with which you want to mix. The desired value will be controlled by an encoder system that detects the whisk cycling speed. In this way, the system allows you to check if the machine has reached your desired mixing speed. Also, you will be able to select the amount of liquid you want to pour by introducing what weight you want your beverage to have. In the app, you can monitor the current weight and the state of the machine in every moment. As you see, the system is currently completing 130 grams of mix with water. You can repeat these two functions in any order until you get the perfect chocolate. Additionally, the system monitors temperature, weight, and mixing speed in every moment to confirm that your chocolate is prepared under your preferred conditions. The best part? You can control everything from your couch with the Wi-Fi control app that you can download in your computer or phone. So, let's get started! These are the materials you need to create your own chocolandes. Please pause the video to take note. Okay, let's follow the steps. The first step is to access to the link of our official GitHub organization where you can access Chocolandes' 4 main repositories. In Chocolandes pack, you will find a detailed explanation of the electrical connections you have to do, along with the ESP necessary codes. Then, in Chocolandes PCB repository, you will find all the files needed to print or edit the PCB. Next, in Chocolandes base, you can download all the PDF and STL files to print or cut the structure. Finally, in the Chocolandes app repository, you will find all the front and back end files needed to use or modify the app.
In the Chocolandes PCB repository, you will find the schematic file that contains all the components used and the connections made between them inside the chocolate maker. The electrical connections are quite simple, so first, let's see how to connect the load cell. In order to get the current weight of our mix, we use a 1 kg load cell and the HX711 module. The load cell is a Wheatstone bridge that changes its resistance value with pressure. You have to connect the load cell to the module as shown in the figure. This way, the module will convert the analog signals to digital values and it will communicate with the microcontroller. Remember to power the module with 5 volts and to connect the data and clock pins to the ones specified in the ESP32 main. Now we will see the connections for the motor pump and the driver used to power it. In order to get enough current to power the motor pump, you have to use the L293D motor driver. This driver works for 2 motors, so you are just going to use half of the pins. The pump is directly connected to the out pins of the driver and the input signals are connected to the digital pins of the ESP shown in the figure. Remember that the logic of the driver works with 5 volts, but you could energize the pump up to 9 volts. Let's see how to connect the stepper motor that is used to mix the content. We are using a NEMA 17 stepper motor and the A4988 motor driver. The motor coils are connected to the driver as shown in the diagram. Likewise, the control signals step, direction, and enable are connected to the digital pins of the ESP shown. Note that the reset and the sleep pins must be connected between them, and the entire module is energized with 5 volts, while the motor is energized with 12 volts. Now we are going to see the connections of the optical encoder used. The encoder allows us to check the speed of the motor at all times. You just have to power it with 5 volts and to connect the data pin to the one specified in the ESP32. The last component that we are using is a temperature sensor. The digital temperature sensor is very simple to connect. You just have to power it with 5 volts and to place a 4.7 kilo ohms resistance between the 5 volt signal and the data pin. The next step is to test the code provided on the Chocolandes back repository. You will have to upload the codes using the Arduino IDE. Remember that we are using 2 ESP32 microcontrollers. So first test everything separately and then try the whole system. The main code goes inside the ESP that connects to the Wi-Fi and controls the motor pump, load cell, and temperature sensor. The stepper code goes on the second ESP32, the one that controls the stepper motor and the encoder. The next step is to make your own PCB. The Chocolantes PCB repository contains the board and schematic files used to make the design. If you want to change something, you must open them with Eagle Desktop. The model we provide is ready to be assembled. You just have to send the Gerber files to the PCB company of your choice and then solder all the components. Inside the Chocolantes base repository, you will find the STL files that were used to 3D print the base supports, the encoder support, and the mixer that were used in the chocolate maker. You will also find the cutting plans of the base that you should send anywhere with a laser cutting machine. Once you have all the parts of the structure, you have to assemble them with the threaded rods and fix them with the M4 bolts.
Step 6. Connect all your systems to the app. The implementation you will find on the Chocolantes app repository is an app that was created in the React Native framework. The app is controlled via Wi-Fi and can be used in Android, iOS, or in your web browser. With it, you will be able to receive updates every second of the system state, send commands of mixing speed or desired liquid to pour, and a status section to check if the commands are being received by the machine. So, if you just want to test the current version of the app, download the Chocolantes APK file on your phone that you can find in our Chocolantes app repository. Connect to your ESP Wi-Fi network and you will be ready to test and serve all your drinks. However, if you want to make changes to the app, you have to download the Expo Go app on your phone and the Node.js on your computer. Then, clone the Chocolantes app repository on your computer and open your command terminal. Navigate to the folder where you cloned the repository and run npm install expo. Afterwards, run npm start. This should print a QR code that you should read with your phone. Once you have done this, you can now edit your code and you will see the changes on the app on your phone.
It is important to remark that this project was carried out during the Electronic Instrumentation class of the Electronic Engineering degree at the Universidad de los Andes. Therefore, there are some things that can be improved. For example, you can adapt the structure and the application as you wish. Also, you may want to use a Wi-Fi router to extend the signal generated by the ESP32, because we realize that the range is quite small. Finally, it will be very cool if a heat system were added to the device in order to warm your beverage. Now you can have your own homemade chocolate maker. Thanks for watching.